Okay, chapter 5. Is all about quadratic functions. So we're going to do more factoring in this chapter, but we're going to be doing a lot of stuff with graphs of quadratic functions and all the specific parts of quadratic functions. So, first of all, we're going to talk about transformation, something that we've done with absolute value, we've done it with linear functions, and we've just done it with points. So we're going to first of all do transformations of quadratic functions. So in chapters 2 and 3 we studied linear functions, so the form mx plus b. And a quadratic function is a function that can be written in this specific form here. And this form is also called, it's called vertex form. And vertex form, this is a very important part. We'll be using this form a lot in what we do. Okay. So vertex form is one of the things that you're going to want to write down because it's something we'll come back to quite often, but you're going to use it a lot today. And vertex form tells us a couple different things. It tells us where the vertex of a quadratic function is, and it'll also tell us what kind of transformation has happened to it. So we've got the linear parent function, f of x equals x, and the quadratic parent function here, f of x equals x squared. So we're going to be working with the quadratic, and so our basic form here of x squared and has these table numbers here. And so one of the big things we're going to talk about is that when we are graphing a quadratic function, that unless there's a stretch or compression vertically, then it's almost always going to go over 1 and up 1, and then if it goes over 2, it goes up 4, because when we square 2, we get 4, right? Okay? And the same with going to the left. If we go over 1 to the left and we square that number, we get 1. If we go over 2 to the left and we square that number, we get 4. So a parabola is always U-shaped, and we will talk about when it opens up and when it opens down. So whether it smiles when it opens up or it frowns when it's opening down. So first thing we're going to do is work on graphing a quadratic function using a table. Now, the standard quadratic function, the parent function x squared, is always a graph that is here at, it always starts at the origin, the parent function does, and then it goes 1 to the right and 1 up, and then over 2 and up 4, 1 to the left, over 2 and up 4. And then the graph is there. Well, we're going to be looking at transformations from that graph, but first of all, just looking at drawing these graphs using a table. So what number do you think we should start with?
3.
Okay. Start with 0. Why, Lexi, do you think 0?
Because we have like the starting point.
Okay, that'll give us the starting point. Okay, the y-intercept always gives us the starting point. Okay, so if we put in 0 for x, then what value am I going to get for y?
3.
Okay, 3, because we got 0 squared is 0, minus 4 times 0 is 0, so this is 3. So our first point is at 0, 3. Alright, so where should we go from there then? What would be a good next number to use?
1.
1 would be a good next number to use, okay? So we'll put 1 in. So I've got 1 squared minus 4 times 1 plus 3. Let's see, what's 1 squared? Okay, and then multiply 4 times 1, I get 4. Okay, negative 4 then. And negative 4 plus 3 is negative 1. Okay, so we have, at 1 we have negative 1. Now, we know that a quadratic, the graph is going to look, it's either going to look like this, or it's going to look like this. Now, since this graph is coming down here to the right then, okay, as I move to the right, do you think I should pick a negative number to go in here then?
Yeah.
Okay, you think we should try a negative number? Okay, so let's try -1 and see what happens with -1. And you've all got your calculator, right?
Yeah.
Okay. So we've got -1 squared minus 4 times -1 plus 3. So -1 squared is 1. -4 times -1 is 4, and 4 plus 3 is, okay, so we have 1 plus 4 plus 3 is now 8, right? Okay, so we have -1 and 8, so that's approximately there. Alright, so now, do you think the graph, do I still want to go with more negative numbers, or do you think I should go with positive numbers now? Okay, positive numbers, because this graph is going to end up going, it's going to end up looking like this somehow. I'm not sure exactly where it's going to go, but it's going to look something like that. Okay? Because as it's coming down here, all right, it's going to have to come back up. Well, when I went to the left, it just kept going up. So now it's going to end up going to the right. So we need to pick more positive numbers then. All right, so let's pick +2. What do we get when we put +2 in there? Let's see, 2 squared is 4. Okay. 4 times 2 is 8. So 4 minus 8 is, and -4 plus 3 is -1. Okay. Okay.
It's supposed to be 0.
The second one.
What's that?
The Y is 0.
The y is 0.
At 1.
At 1 it should have been 0?
Yeah.
Oh, because I lost that +1 there, didn't I? Alright, here. That should have been 0. -1. Okay, so it's going to keep going to the right, so let's put 3 in here now. Alright, see what we get. What's 3 squared?
9.
9. Okay. And 4 times 3 is?
12.
Okay, so what's 9 minus 12? -3. And -3 plus 3 is? 0. Okay. So what do you think is going to happen now?
You're gonna graph.
Okay. So where do you think the next point is going to be at?
3.
3.
Okay. At
4.
4 and 3. Now the one thing that you're going to learn about that we know about quadratic functions is they're symmetrical, okay? Which means that there's a line that we can cut the graph in half in, and actually there's a vertical line here then, and we'll talk about this more later. This is called the line of symmetry, or the axis of symmetry, and the graph has to be exactly perfect on both sides of that. So if I have this point, if this point right here is my vertex, okay, the very bottom point, or the minimum value, is there, then the rest of the graph is going to be equal on each side. So that means I could come up here to 5 and go up here to 8 also. So I have this graph then. And please, when you draw those graphs, this is rounded here, okay? All right, it's not an absolute value of the graph, which some people tend to draw. So make sure you make it rounded there. So when you draw your graphs, all right, you're going to use some positive and negative values for x to make sure that your graph is either going to go up like this one does, or may go down like that one there does. All right, so there's graphing using the table. All right, let's talk about our transformations now. one thing I forgot to give you is we're gonna need some graph paper. How many of you have some graph paper still in your folder or binder somewhere? Okay, most of us do. All right, some of us do.
I was all holding it in.
Yeah, I'm giving you a few sheets, so you got plenty there to draw on. All right, so transformations. First of all, okay, we wrote down that vertex form a minute ago. I'll write it down here again. So in the vertex form, H and K talk about translations, okay? Movements left and right, just like they did when we used the vertex form, basically for the absolute value functions. We had a vertex form there. And so H and K do the same thing they did with the absolute value. H is a horizontal movement. If it's positive, it's a movement to the right. If it's negative, it's a movement to the left. And K is our vertical translation. If it's positive, it moves the graph up. If it's negative, it moves the graph down. So we're going to do some translations. The first thing we want to do with our translations is identify H and K. Because once we identify H and K, then all we have to do is shift the graph over there. So here's the graph of x squared. So when we identify H and K, then all we're going to be doing is taking that graph and moving it left and right, up and down. So in this problem, okay, what is H and what is K? Okay, H is 2, K is 4. So this means that I have taken this graph and I have translated it 2 units to the right, because H is positive, and 4 units up because K is positive. So I now have my vertex point is now at 2, 4. Now since I haven't done any stretching or shrinking, from that point there then, I just take my normal quadratic function and I'm going to go 1 to the right and up 1, 1 to the left and up 1. And then you go 2 to the right, you can go up 4. 2 to the left and go up 4. And then I'll draw my graph. 2 left and up 4. Try to make it. And there's my transformed graph. So identify H and K, move it to that new point, that's your vertex point, that value of H and K is your vertex point. And so you're just going to move the graph there, and we move 1 left, 1 right, go up 1, move 2 right and 2 left, and go up 4. Letter B. What are H and K here then? H is, what is it?
2. -2.
It's -2, okay? H is always the opposite because the vertex form is x minus h. So h is always the opposite of what's inside the parentheses there. So h in this case is -2 and k is -3. So we're going to take this graph here. So we're going to take this graph and we're going to move it to the left and down 3. So I'm going to take it and I'm going to move it over 2 and down 3, and there's my graph. So I'm still from that vertex point, this is my vertex point, -2, -3. So I put my vertex there, I'll go over 1 and up 1, over 2 and up 4, both directions, to make my graph. So don't forget that h is always the opposite. Okay, there's translations. We have reflections, okay, horizontally and vertically. A horizontal reflection f of -x, well, if I put -x in there and I square it, I just get x squared. So horizontal reflection basically just reflects it on itself. A vertical reflection, like we have here then, is going to flip it upside down because it's a reflection over the x-axis. So here's the way you can think of this, all right? Normally it looks like x squared, so if the x squared is positive, then it's going to do what you do when you're positive. And what do you do when you're positive? What's your facial expression when you're feeling positive?
Frown.
Right, you smile, okay? All right? And when you're feeling negative, you frown. Thanks a lot for playing along, gosh. Okay? So, that's one way you can think of it, is when x squared is positive, the graph is going to open up like a smile. When x squared is negative, it's going to open down like a frown. Stretches and compressions. All right, we've talked about these, okay? Horizontally, it's always the reciprocal is what it does. So if we have a stretch or compression by a factor of b, then that means it's going to be 1 over b. We're multiplying by x in those cases. If b is greater than 1, it stretches it horizontally. If b is less than 1, then it compresses it horizontally. The value of a, okay? Vertical stretch means is it stretches it vertically, and if it's between 0 and 1, it compresses it vertically. And this is actually, these are backwards. Okay. When b is greater than 1, it compresses it. When b is less than 1, it stretches it horizontally, because it's the opposite of what these are. All right. Okay, we have g of x equals -1/4 x squared. Now, one of the things that actually might help you is using the normal values for a quadratic, for a table. And normally, if you're making a table with a quadratic function, then your table will look like this. That you might use these values here, so that you have 4, 1, 0, 1, and 4. Okay? So if I move over 2, I go up 4 or down 4. If I go over 1, I go up 1 or down 1. So here this says -1/4 x squared. So this means we're taking all of the y values and we're going to multiply them by -1/4. So think about taking all of these y values and multiplying them by -1/4. Okay? What's 0 times -1/4?
0.
0. So we've got the 0.00 still. What's 1 times negative 1/4? Okay, negative 1/4. So positive 1, I have negative 1/4. And at negative 1, okay, I'm going to have negative 1/4. What's negative 1/4 times positive 4? So negative 4 times negative 1/4 is negative 1. So at 2 and at negative 2, I'm going to be at negative 1. So I've compressed, because this number is less than 1, the absolute value, I'm compressing it vertically. And it's also going down because of the negative. So I took this graph here, took that graph there, I reflected it over the x-axis, and I compressed it by 1/4. So my y values then were only 1/4 of what they were here. Okay? So they became negative because of the reflection, and then they became 1/4 less because of the compression. Letter B, the quantity 3x squared. Now remember, okay, when we're talking about it, when it's in the parentheses, it's a horizontal change. And whenever it's horizontal, it is the reciprocal. So we're talking about here that B is, in this case, equal to 1/3. So this means that we're going to be compressing it by 1/3. Not stretching it by 3, but compressing it by 1/3. So we're going to take the x value. So I'm going to look back at this table I was using here, okay, and now I'm going to multiply all the x values by 3. So let's take our x values. All right, the first one is negative 2. What happens when I multiply negative 2 times 3? What do I get? Negative 2 times 3 is negative 6, right? Okay. So I go over to negative 6 and I go up 4. Because if it's a horizontal stretch or compression, does that affect the y values? Okay. All right. It does not affect the y values, it affects the x values. So 3 times negative 2 is going to give me negative 6, 4. 3 times negative 1 is? Negative 3. So I have negative 3, positive 1. 3 times 0 is? 0. So we still have 0, 0. So all I'm doing is taking this, my standard y equals x squared, my parent function, the regular table of that parent function, and all I'm doing is multiplying. If it's inside the parentheses, I multiply the x values. If it's outside of it, like it is here for a, then you multiply the y values by it. So 3 times 1 will give me 3 and 1. And then 2 will give me 6 and 4. And I draw my graph. Oops. Something better than that, I hope. So 3x is actually stretched it horizontally. But all I'm doing with these, both of these two then, all right, if it's outside, it affects y. If it's inside, it affects x. So all I did was A, multiply the y values by negative 1/4. With B here then, I multiplied the x values by 3. And then you can just plot those points you're going to get and draw your graph. Any questions? Okay, so your assignment then